You use cables every day, but can you actually name the most common ones? Let's find out.
Different cables have different jobs. Here's how to tell them apart. Each cable has a function. It might carry data, video, storage signals, fiber, or power. Its connector shape tells you exactly what it's meant to do. Some cables are built for speed, others for long distance, and some are designed for tougher or specialized environments. Once you know these four details, you can identify almost any cable you see. Network cables connect your network and let devices communicate. Their purpose is to carry network signals so data can move between devices. There are three main types: copper twisted pair, coaxial, and fiber optic. Copper twisted pair handles Ethernet connections with shielded and unshielded versions. Coaxial carries broadband and RF signals, making it reliable for long runs. Fiber optic uses light for extremely fast speeds over very long distances. Each one serves a different role in how networks move data. You'll see these used in Ethernet networks, broadband lines, and backbone links. Each cable type supports different speeds, distances, and environments. Together, they create the full path your network traffic travels. Let's start with the most common connectors, the RJ45 and RJ11. You've probably seen RJ45 and RJ11 connectors before, but do you know what makes them different? Here's how each one works and where you will find them. The RJ45 connector is the one we use for internet and network. It has 8 wires, it's a little bigger, and you'll see it on things like your PC, router, switch, and wall network ports. The RJ11 connector is the smaller one that's used for telephone lines. It only has a few wires, and it's really just meant for voice communication. The easy way to remember is RJ45 is for internet and networking. RJ11 is for phone and voice. RJ45 is bigger, carries more information, and is the standard for modern networks. Copper twisted pair is the standard cable used for Ethernet networking. It uses an RJ45 connector and contains 8 copper conductors arranged into twisted pairs. Those twists help reduce interference, which keeps the signal stable and reliable. You'll find this cable in most LAN networks because it's simple, effective, and widely supported. Shielded twisted pair is an Ethernet cable designed to block interference. It uses a foil shield around the twisted pairs, which helps protect the signal from electromagnetic noise. STP is used in places like factories, hospitals, and other noisy environments where regular Ethernet might struggle. Because of the shielding, STP needs proper grounding to work correctly and safely. Unshielded twisted pair is the most common cable used for indoor Ethernet networks. It doesn't have any shielding. Instead, the twisted pairs themselves help reduce interference. UTP is used in homes, offices, and most indoor network setups because it's simple, reliable, and cost-effective. Ethernet cables use two main termination standards, T568A and T568B. These are just two different ways to arrange the colored wires inside an Ethernet cable. The cable works the same, the only difference is the order of the colors. T568A uses the green pair in positions 1 and 2. T568B uses the orange pair in positions 1 and 2, and it's the most common standard today. If both ends of the cable use the same pattern, that's a straight-through cable, which is what you use for normal network connections. The main rule is simple: pick one standard and match both ends. Most people choose T568B because it's widely used. Remember, the only difference between T568A and T568B is that the green and orange pairs swap places. Everything else stays the same. Ethernet cables come in different categories, and each one supports a specific speed and performance level. Cat5e is the most basic, supporting up to 1 gigabit. Cat6 improves performance and can reach 10 gigabits over short distances. Cat6a extends that 10 gigabit speed across the full cable length. Cat7 adds heavy shielding for specialized environments, and Cat8 is designed for high-speed server rooms, supporting up to 40 gigabits over short runs. All of these twisted pair Ethernet cables use the same connector, the RJ45. Direct burial cable is designed for outdoor and underground environments. It has a thick, rugged outer jacket that protects the cable from moisture, soil, and harsh conditions. This type of cable is used when you need to run Ethernet outside or underground, where a standard indoor cable wouldn't survive. Direct burial cable must be rated for burial. Plenum-rated cable is designed for air handling spaces, like the area above drop ceilings. It's a low-smoke, fire-resistant Ethernet cable, built for environments where safety is a priority. Its special jacket helps limit smoke and slow flames spread, adding an extra layer of protection. You'll typically find it above drop ceilings and in other air handling spaces throughout a building. These cables are often required by building codes, and because of their safety features, they're usually more expensive than standard Ethernet cable. Coaxial cable uses one center conductor to carry signals. It works by using insulation and shielding to help move RF signals with low interference. You'll see coaxial cable used for cable internet, TV lines, and CCTV systems. And an important detail, it often uses F-type connectors. This is the F-type connector, the familiar screw-on coax connector used in many home setups. It's a screw-on connector for coaxial cable, designed to create a reliable connection. Its threads twist onto the cable, giving you a secure RF connection that stays in place. You'll see it on cable TV lines, cable modems, and satellite setups throughout homes and small offices. It carries RF signals and is very common in home installations, making it one of the most widely used coax connectors. Fiber optic cable sends data as light through thin strands of glass or plastic, allowing fast, efficient communication. It works by sending light pulses through the core, making it immune to electromagnetic interference and keeping signals clean. Fiber is used in backbone links, long-distance runs, and high-speed networks. And importantly, it supports very long distances and high bandwidth, making it one of the most reliable options available today. Fiber comes in two main types, single-mode and multi-mode, and each carries light very differently. Single-mode fiber has a very small core and carries a single light path. Those paths bounce and spread out, which limits how far the signal can travel. Multi-mode fiber has a larger core and carries multiple light paths at the same time. Single-mode fiber uses one narrow light path, making it ideal for long-distance links with very low loss, like building-to-building or long-haul connections. Multi-mode fiber uses multiple light paths and is best for shorter runs inside buildings and data centers. Remember, the key difference is the core size, which controls how far the fiber can carry light. Now let's look at the most common fiber connectors: straight tip, subscriber connector, and lucent connector. ST connectors use a twist-style bayonet design. They're round and lock in place with a quick twist. SC connectors use a square push-pull design. They're easy to plug in and unplug, which makes them common in older fiber setups. LC connectors are the smaller form factor version. They're used in high-density equipment where space matters. The easiest way to identify fiber connectors is by their shape. In every structured cabling system, there's one small component that keeps everything organized behind the scenes: a punch-down block. A punch-down block isn't a cable, it's a termination point. It's where network wires come together and get organized. Its job is simple: securely terminate each wire. Each wire is pressed into IDC slots for a solid, reliable connection. You'll find punch-down blocks in wiring closets and structured cabling systems. They keep cable runs neat, labeled, and easy to manage. The block doesn't carry the signal, it organizes the cables that do. A small component that keeps networks clean, structured, and dependable. Every computer setup relies on simple connections that make external devices come alive, and that's where peripheral cables come in. These cables serve one main purpose: connecting external devices to your system. Whether it's USB, serial, or Thunderbolt, each cable carries data and sometimes power to the devices you use every day. Devices like keyboards, mice, printers, and external drives all depend on USB connections to operate. Peripheral cables may seem basic, but they're essential for keeping your devices responsive, powered, and ready to work. USB versions determine speed, while connector shapes only determine how devices plug in. USB 2.0 runs at 480 megabits per second, and USB 3.2 Gen 1, also called USB 3.0, reaches 5 gigabits per second. USB-A is the standard rectangular connector, and USB-C is the newer reversible connector that supports multiple USB versions. Newer versions include USB 3.2 Gen 2 at 10 gigabits per second, Gen 2 by 2 at 20 gigabits per second, and USB 4 at 20 to 40 gigabits per second. Speed always depends on the USB version, not the connector shape. Many older devices rely on connector types that came before USB-C, and two of the most common are mini USB and micro USB. Mini USB is the thicker, trapezoid-shaped connector. It was common on older cameras, MP3 players, and small electronics. Micro USB is thinner and flatter. It became the standard on older phones, tablets, and many Android devices. Both connectors only insert one way, and neither is reversible like USB-C. Knowing the shape helps you quickly identify which connector fits which device. USB-C is the modern connector used on today's devices. It's small, reversible, and plugs in either direction, making it easy to use. USB-C can carry data, power, and even video through one port, which is why it's become the new standard. Older devices may still use mini USB or micro USB, but USB-C offers far more flexibility. And remember, connector shape doesn't guarantee speed. Performance depends on the USB version behind it. Thunderbolt and Lightning look similar at a glance, but they serve very different purposes. Thunderbolt is a high-speed connection used for data, displays, docks, and advanced devices. Thunderbolt 3 and newer use the USB-C shape, but not every USB-C port supports Thunderbolt. Lightning is Apple's older mobile connector. It was used on many iPhones and iPads before Apple moved to USB-C. Even though some connectors look alike, the features behind them can be completely different. Some older technologies are still around because they remain useful in certain environments, and serial connections are a perfect example. Serial communication is an older method used for console access and legacy equipment, and the DB9 connector is the most common form of it. You'll still find DB9 ports on industrial gear and older IT devices, especially when connecting to routers, switches, and firewalls. It's slower than modern USB, but it remains reliable for console and legacy connections. Video cables carry the picture from your device to your display. And today, the most common types are HDMI, DisplayPort, DVI, VGA, and USB-C video. These cables are used on monitors, TVs, laptops, and projectors. HDMI and DisplayPort are the modern standards, while DVI and VGA come from older generations. USB-C can also carry video on newer devices. Each connector has its own shape and supports different video standards, so recognizing them helps you choose the right cable for your setup. HDMI and DisplayPort are both digital video connections, but they're used in slightly different places. HDMI is common on TVs, consoles, and laptops. It carries both video and audio, making it the standard for home entertainment and general use. DisplayPort is more common on PCs and graphics cards. It's designed for high resolutions and high refresh rates, which makes it ideal for gaming and professional monitors. Both deliver digital video, but the devices they're used on and the performance they support are what set them apart. DVI and VGA are older video connections that you mostly find on legacy systems. DVI is a digital connector. It's larger, usually white, and was used on older digital displays before HDMI and DisplayPort became standard. VGA is even older. It uses a blue 15-pin connector and carries an analog signal, which means the image quality depends heavily on the cable and the device. Both connectors still appear on older monitors and projectors, but modern systems have mostly moved on to digital standards. A key difference is that DVI is digital and VGA is analog, meaning DVI gives a cleaner, sharper picture, while VGA can look softer because it uses older analog signals. USB-C video refers to a USB-C port that can send video output. It works by sending video through adapters to HDMI or DisplayPort. You'll find it on laptops, tablets, docks, and other modern devices. One important detail is that the USB-C shape alone doesn't guarantee video support. It depends on the port's capabilities and the cable you're using. SATA is the serial ATA interface used for internal storage in computers. It connects hard drives and SATA-based SSDs using two separate cables, one for data and one for power. You'll find SATA in desktops, older laptops, and other legacy systems. It replaced the older PATA standard, and today NVMe is the modern high-speed alternative. Next up is the MOLEX connector. MOLEX is a legacy 4-pin internal power connector that was used in older desktop PCs. It supplied power to older hard drives, optical drives, and even some case fans. You'll recognize it by its large white 4-pin design. And while it was common years ago, it's now rare in modern systems. Most newer components use SATA power instead, but MOLEX still shows up occasionally in older hardware. Quick recap. Here are the most important things to remember. Copper twisted pair is the standard cabling used for Ethernet networks. UTP is unshielded, while STP adds shielding to help reduce interference. Ethernet categories like Cat5e, Cat6, and Cat6a determine cable performance and speed capabilities. T568A and T568B are the two standard Ethernet wire pinout patterns. RJ45 is the common connector used for Ethernet. RJ11 is smaller and is commonly associated with telephone connections. Plenum cable is designed for air handling spaces where fire safety matters. Direct burial cable is designed for outdoor or underground installation. Coaxial cable is commonly used for cable internet and television. F-type is the connector commonly used with coaxial cable. Fiber optic cable transmits data using light and supports high speeds and long distances. For fiber connectors, remember ST, SC, and LC. A punch-down block is used to terminate network cabling. For USB, remember that the USB version determines performance, while the connector type determines the physical shape. Common USB shapes include USB-A, USB-B, mini USB, micro USB, and USB-C. Thunderbolt is a high-speed connection, and modern versions commonly use the USB-C connector. Lightning is Apple's older proprietary mobile connector. DB9 is a legacy serial connector commonly associated with RS-232. For video, HDMI carries digital video and audio. DisplayPort is another digital display connection and is commonly used with computer monitors. DVI is mainly a legacy digital video connection. VGA is the older analog video connection. USB-C can also carry video when the port and device support it. eSATA was designed to connect external SATA storage devices. SATA data carries data between a drive and the motherboard. SATA power supplies power from the power supply to the drive. MOLX is an older power connector commonly found with legacy drives and fans. Those are the key associations to recognize for the exam.
Now you know the most common cables and connectors, and how to identify them with confidence.